musical. If you have the music, good morning, our amazing teacher. You are welcome to day 2 of the National VEX Robotics Coding Competition. I believe that day 1 was awesome, and I believe that you have something to take home. And I also believe that you have been practicing what you did in day 1. So day 2 is full of activity and hands-on activity, and I hope that you're going to enjoy day 2. Just a recap of what we've done at day 1. First, you need to know that this competition is in 3 categories. We have the elementary school, we have the middle school, and the high school. The elementary school are the primary school students. They're eligible for this competition. The middle school is for junior secondary school, and the senior school is for senior secondary school. Okay, so if you belong to any of these, if your school belongs to any of this category, you can sign up for this competition. If you want to sign up for 2 categories also, that is possible. I mean, if you have both middle school and high school, or both middle school and elementary school, or both elementary school and high school, you can also sign up for this competition. So throughout this competition, our competition field is going to be using mail solver, disk mover, castle crusher, treasure hunt, and coral reef cleanup. Okay, so we're going to be engaging on all these playgrounds. So yesterday was awesome. We started with castle crusher, and our amazing tutor taught us on how to move our robots to be able to crash into castles. Okay, it's very, very important for you to know some key dates also, just to reinforce or to emphasize on what the necessary of this timeline. First is that entry open on 27th of October. We'll be having amazing sign up, but some people are still yet to sign up. If you've not signed up, please do so. We're going to be closing every sign up today by 7 p.m. So do all what you can to ensure that you sign up. Okay, so our submission for our project also is on 7th of December 2025. Okay, that's after this training, you're supposed to submit your project, and our winner will be announced mid-December 2025, and the national finals will happen in Abuja on 30th of January. Okay, so our registration process, as you know, you must provide at least 3 to 5 students, from 3 to 5 students, sorry, and a mentor or a teacher. And your mentor or the teacher must join our WhatsApp group. It's on the link below. So just click on the WhatsApp group and you can join our WhatsApp group so that you can get all our resources and information that may be sent ahead. Okay, so these are the modalities for the competition. After this period of this training, your student need to now engage in the competition that will be sent, and they need to make a 2-minute on-call video introducing the name of the school, the name of the team or the team member, why they are excited about robotics and coding, and after doing this video, they need to upload it on either a YouTube page or a Google Drive. It's good to put it on private mode so that you can send it to us so that we'll have access to it exclusively. But if you don't have YouTube, you can do Google Drive. That is also fine. But while you are sending the YouTube video, you need to send the code as well together. This should be done before 7th of December 2025. So we also talk about our judging criteria, that every completed task will be 40%, and code efficiency be 25%, creativity and problem solving will be 20%, and team presentation is 15%. And there's also reduction for points if you violate some of these rules. One of it is if you have late submission, it's going to be minus 20 marks or 20 points, and incomplete submission is minus 10 points. Okay, so if you have not subscribed to our YouTube channel, please do so now. Just click on the subscribe button and like our page and make comments, because this helps us to create awareness so that other audience can get access to these resources. And also, even after this training, we are going to be creating some other content, other teaching, other materials that can help you. So when you subscribe, you'll be able to see this information first hand. Okay, so just to make a recap of what we've done yesterday, in case you miss it. So the first thing you need to do is to go to your browser, then open your browser, any browser of your choice. After opening a browser, you go to vr.vex.com. vr.vex.com. I'm going to type that vr. Look at it on the screen. vr.vex.com. Then I'm going to click enter. vr.vex.com. Okay, so you give it some time to load. Okay, so I just give it some seconds to load. Okay, perfect. Okay, so this is the first thing it will show you welcome to VEX Code VR. This is the interface where all our students will be engaging. As an educator, you can sign up here. You can say you're an educator, get started as an educator, or your students, it can be students, get started. So I'm going to assume that I'm a student. So I'll click on student, get started, and immediately you get started, it will welcome you, and you can just simply click next. Okay, so as you can see, to the left-hand corner, my own left-hand corner, it's the toolbox. As you can see, you see drive forward. This is where all the blocks for your programming will be. So you can take your time to go through all the blocks in the toolbox. Then, when started, this block here is where you attach all the blocks or all the programs that you want to run. So any block that you put on this white space that is not attached to when started will not be run. So when you want to run the program, when you want to write a program, everything should be in under when started. So next, you're going to see, when you finish programming and you want to test your program, then you click on the start button. The start button is to start your program. And if you want to select a playground, where you're going to choose the task that will be given to you, you click on select playground. So if you click on select playground, there are a range of playground that are available there. Then you're going to choose the one that was given to you for the competition. After selecting playground, you're going to see if you want to save your program, you click on save. The save is under the file. Once you click the file, you're going to be a drop down menu, and you're going to see save. Then you can save your project. We're going to also do this. We're going to do it practically. Okay, if you need help in any area, you can click on the get help, and you can get as many help as you want. And if you're confused at any point in time, you want to see some example code that's been written by professionals, so click on open example. Open example, open range of code that have been already pre-written for you to study and for you to understand how the program or the code work in case you are new to programming. Also, if you need exclusive tutorial that will help you, you click on try out a tutorial and you can get access to tutorial. If you need more, you can also learn more from there. Okay, so this is for changing language. I don't think you need to change any language. It's always in English. So we are English speaking country, so you don't need to go through that. This is where you're going to monitor every activity that happens right inside your robot. You can check the speed of the robot. You can check the sensor. You can check what the robot's brain is thinking at an instant of time. That's why you click the monitor button to monitor what is happening inside if you need to get that. Okay, so you can also give feedback if you want to give feedback on how they can improve this platform. Okay, so that is all about introduction for you. So I have an exciting news to share with you. Okay, so after the completion of the program yesterday, we received a mail from the VEX. They saw the good work we are doing, and I want to announce to you that at the end of this program, the certificate will come directly from US, directly from VEX. The certificate, initially we want to give you the certificate ourselves, but now they've seen the quality of the work we're doing, and they have decided to issue the certificate directly from US. So it now means that we want to give this certificate to people that are truly worth it. So if you have not been engaging, they have not been participating, we may not be able to give you the certificate. I'm sorry. However, we may decide to issue you the one from our company. But for the VEX certificate, for the one coming from the US, you need to be active member. We need to know that you actually know these things before we can issue out this certificate. This is a strict warning from the US, so you have to obey that rule. Meanwhile, I will also want in the comment section, please go ahead and comment the name of your school, where you're coming from. We want to see it in the comment section. That will help us to know people that are engaging on our platform, and we'll be able to help us to take daily attendance for people that are actually joining. So please do that right away. Do that right away. Just type the name of your school, where you're watching from, and we want to see that. Please, we want to see that. That is very, very important for this session. Okay, so just to give you a rundown before our next facilitator comes in, I want to give you a rundown of what we've done in our last class, that's yesterday. So the first thing you need to do after opening this playground is to go to select playground. If I click on select playground, you just scroll down. Sometimes people may find it difficult to scroll down. So the first thing, one of the way to scroll down is to just tap once on the white area of this place. Then use your down arrow key on your keyboard to scroll. Then to scroll down. Then you can see this platform here, all this one that requires VR premium license, they are premium license. I mean, you can't access this except you buy the premium license, and the premium license is close to $900. If you want to, yeah, you can actually buy it. So there are world competition playground there, as you can see. Some of them are just last year playground that are 3D immersive. Okay, so but we're going to be giving out the license to winners as well. So that's getting more than $900 if you understand that. But you can have access to the free one if you don't want to pay for the license. You can have access to the free one. These are the free one. We have the art canva, we have the castle crusher, we have the coral reef cleanup, Biggs maze, Biggs mover, and the rest of them. So the one we're going to be engaging on today, that we engaged on yesterday, was the castle crusher. So I'm going to just click on it. When you click on it, the playground will be open. The playground will be open. Just give it some seconds for the playground to open. Okay, while the playground opens, since you already understand what the playground is all about, there are some castles that you need to kick down. You need to push them down. So before you enter any program, that is your first step. Study the playground. What are the elements on the playground? What are the things on the playground? Does my playground has boundary? Does my playground don't have boundary? You know, when your playground don't have boundary, it's possible that your robot can fall off the cliff. While if your playground has a boundary, you know that you can easily kick the wall. So you have to analyze your playground. That's your first step. Now, so for the castle crusher playground, I know that the first thing you're going to notice is there are different castles there, and these castles are detachable. Okay, then the next thing I'm going to think about is, okay, how well can I crash on any castle? How well can I crash on it, and how fast can I achieve this task? Okay, now as you can see in our toolbox, we have drivetrain. Drivetrain is anything about driving and turning. You're going to see, if you need a block about driving and turning, you're going to see it on the drivetrain. If you need the robot has some sensors on it. One of the sensor, okay, I think our facilitator will introduce you to all the sensors that are available on the robot. Okay, but if you need anything about magnet is here, drone is here, sensor is here, console. This console is when you want to print on the screen. Okay, we are going to introduce you to this also very soon. And then if you need logic, anything about logical thinking, which is the main highlight of this training, knowing how to use repeat, knowing how to use forever, knowing how to use control. Yeah, that is the beauty of the programming. So this is where you come. So our instructor yesterday used so much of the drivetrain, so I'm going to go back to the drivetrain. So the first thing you may want to do is to either drive forward or drive forward 4. Okay, in the course of the training, you're going to know the difference between the two. For now, I'm not going to tell you the difference between the two, between the drive forward and the drive forward 4. However, both of them drive forward, but they do not perform the same function. So I'm going to just use the drive forward 4. Then I can decide to specify a distance. Let's say I put 1000. Then if I play it, my robot will drive forward for 1000. Oh, so sorry, my playground is taking time to load. But of course, you already know what the playground look like. If you need to turn, also, I'm just giving you introduction of what we did yesterday. So if you need to turn, we have turn right. We also have turn right for also. If you click on turn right, you can either turn right or turn left if you want. And if you want to turn right or turn left, you can specify the degree. Also, the first one, you can't specify the degree, but the second one, you can specify the degree. I'm not going to tell you the use case of these two. Subsequent training, you're going to see when to use turn right or when to use turn right for. So for now, I'm going to just use turn right for 90 degree. That's if you want to turn right for 90 degree. But if you want to actually turn left, you change the right to left. Okay. These are the basic block. Now I'm going to also introduce you to the drivetrain velocity. In case you want to increase the speed of your robot, you can increase the speed. It's not every time you need to increase the speed. Sometimes you may just want to increase the speed, and sometimes you may want to lower the speed. The same thing for the turn. You may want to increase the turn velocity or reduce the turn velocity. I believe that I've been able to explain very well. So I'm going to close this playground and I'm going to select it again. Okay, so my playground is taking some time to load. So just wait for it to load while I still continue to explain. Although I've explained the major points that we did yesterday. Okay, it's just that I may not be able to show you how to crash out, but you know, when you drive forward towards the castle, you can push out the castle. But the amazing thing is that our activity today is a new playground we're going to be exploring. Yeah, we're going to be exploring a new playground. Okay, so my playground already open, so I can actually show you. So you drive forward and you see it crash and it turn. So you can play around this. Okay, one other thing I need to show you is the camera view, just as our facilitator explained yesterday. So if you want to see the robot in 3D, you can click on the down camera button. So when I click on the down camera button, I can see how the castle. This helps you to study the playground. As you can see, this particular playground does not have a wall. It does not have a wall, so you must be careful that your robot do not fall off. When your robot fall off the cliff, you are out of the game. The task has ended. Okay, so it's good you check around the robot to see all the possible things you can do around the robot. Okay, so every playground has its own unique robots. Some are the same, some are different. Okay, so at your leisure time, please go over this robots, the playground again. So I believe that I've been able to explain all that there is yesterday. So if you've not subscribed, please go ahead and subscribe. And if you have a question, please type it in the chat box or send it on our WhatsApp group. Any of this way, we are going to attend to your WhatsApp before the end of the training today. Okay, so at this point, I'll call on our facilitator for today to take us on the journey that I've been waiting for. Thank you very much and
Good morning, everybody. I thought I know our training has been good so far. I want to thank our moderator. He has been doing a wonderful job. Thank you, Coach Abiola. He's a great coach when it comes to robotics with his vast experience over the years. I believe we're on the right track. Okay, today we'll be looking at we'll go through all through the magnetic tool. We're going to be exploring the magnetic tool for today. So I'm going to select a playground. I'm going to select a playground. For today, we will be using the VEX mover. Now, as we've all learned how to use the drivetrain, some sensors, and some console and the logic. So we're going to be exploring more of magnetic today. While our playground is still loading, I'm going to be deleting the drive and I'm going to be doing it again. Okay, now this is our playground. This is our playground. As you can see, let me just turn so you can see this is our robot. Now, if you look at our robot very well, you can see there are sensors, and there are cameras all over it. I don't know if you see in front of the camera facing you, the robot, underneath it, you see something black. That's the magnetic sensor, and that's what we're going to be using today. Now, the task for today's challenge is to move all these disks to the square. So we're going to be coding the robot to move all the disks down to the square. Now, if you're following me and you know you can do that, you can just give me a thumbs up on the channel. Give me a thumbs up so I know you're listening to me and I know you're following me. Okay, thank you. Now the task, remember the task is to move the robot to get the disks and bring it back here. We all know before you start any code, you're going to use the drive when. And we can select the forward, go to drive. Now let's explore some of these things before. Now when you use the drive forward, let's play and see. When you use the drive forward, the robot keeps moving without, it does stop. But that's not what we'll be using. I just want to refresh everything that we've learned last time. The drive forward. Now the magnet, just as magnet is, when it moves around to the playground, when he sees the magnet, he does what? He picks. Now the boost here means to pick, and the drop here means to drop. Now let's do a small command. Let's see. The drive forward. Let's use the drive with the distance. Let's say drive forward for 800 millimeter. Then let's use the magnet now. Now we're going to be learning about the boost and drop. So now let's say it moves forward for 800 meters and let's pick the boost. The boost simply means that we should pick up. So whenever the robot moves to where there's a disc, you do what? He boosts, that is, he stops to pick up. Let's just run and see what would. Okay. Then just do a drive back. You can decide to drive, you can decide to turn right and drive for 200 millimeter, so we can see to be sure, so we can be sure that click the discs. No, the aim of this one is just to show what the boost is all about. Okay, okay. Now let's refresh and run it again. Now as you can see, it passed without picking up. So let's look at it very well and do it again. So drive, okay. Okay, now this is the drive and boost. So this is drop to drop. So the robot will go, will pick and it will drop. Let's use the boost. Let's say the robot drives for 800 millimeter. Now remember, each of the blocks here, they are measured in 200 millimeter. So you can for easy calculation, you can just count 1, 2, 3, 4. So from the distance from here to here is 200, from here to here is 200, from here to here is 200, from here to here is what? Another 200. Then if you multiply it, it becomes 800. So when the robot drive for 800, then it will what? Boost. That is, boost means to peak. So let's see. Then let's do a drive reverser. Drive reverser to see if it has picking up the drive. So let's go to the forward, let's reverse. Let's see. Drive. Then see. Okay. Now, as you can see from there, it has just done what? It has boost. So that is the boost, that is to pick up. Now let's see, let's work on the drop. Let's work on the drop. So let's say after you have picked, let's go back to the magnet, then click on the block loading and select drop. Drop, and let's do a drive away. Go to drive train and let's do drive. Let's use the distance. Let's say drive for another 200, just to ensure that it has dropped the discs. So see, it has clicked and it has moved forward. And as behind it, that's where we have the disc. So that's the essence of the drop. So for you to pick up an item or a disc on the playground, you use the boost, and for you to drop it, you use the drop. And remember, the robotics is all about computational thinking, problem solving. Yeah, if you're able to think very fast, you will be able to achieve this particular task in no time. That is the essence of robotics. It's better to build your thinking ability and the ability for you to resolve a problem in a shorter period of time. Now, if we want to continue writing this code, it will take us a longer time to go pick, and drop. I remember our aim is to pick and to drop. Our aim is to pick the disc and to drop on the square area. So let's see. And this is drive forward for 800. Now let's go to the magnet. Let's do click. Then we also go back to the drive train, select drive. Now we can decide to turn left or turn right, but okay, let's see which one is more faster. To decide to turn left, drive to pick, then do a reversal for another 800. Another 800. So let's see. Now, you can see it has achieved that goal of going to click the disk and come back to drop it here. That is doing what? A reversal. But you know, the other ways where you can decide to use drive turn left or turn right until it comes to this place. But how effective will that be? And remember, the task to achieve a particular goal at a particular period of time. So let's just see if we can achieve this in no time. So if you know the next step we can take, just give me a thumbs up, or you can go to the comment section and tell me to turn left or to turn right or to drive forward, so you can know we're actually engaging you. Thank you so much. I saw your comment. You said I should add a drive forward. Yes, that's what we're going to be doing now. We're going to go to our drive frame. We're going to select drive forward. Now remember, I said each cone, each of the boxes are represented with 200 millimeter distance. So we're going to count from here to the next one. Let's count. From here, we'll count 1, that is 1, 2, 3, 4, 5, 6. So 200 times 6, we'll be having 1,200. So we're going to change our drive distance to 1,200. Now this, why we are doing this is for precision, so that our robot will not miss its coordinate or direction. That is why we are driving with distance. So we're going to do, and then the next thing we're going to pick magnetic sensor. Let's select boost. Oh, I just noticed there's a little lapses, and I was expecting everybody to say something about it to show that we're following, but it seems nobody is paying attention. So I'll just go back and do, please, let's follow and let's make sure we're following. Thank you very much. All right, now the lap is here. After you have revised, then you need to do what? You need to drop. You need to what? Drop before you move forward. If not, it will still move with the disc. So we drop, then we not select drive. Now let's see what we've written so far. Okay. Now, so what is the next step? Now the next step is to go back to our drive train, select the drive forward, but this time we're going to be using reverse, not forward again. We're going to be using reverse. We're going to set it with the same distance of the forward distance. We're going to set to 1,200 millimeters. Then let's see what we have done. All right, isn't that amazing? That the robot is so precise. See, the robot can only give out what you have given him. That is why, now why we are using this block coding is to familiarize us with the basic of coding. This pictorial coding, it helps us to understand it better than when we're doing the Python coding. Now with this, we're able to understand the movement, the directions, the conditions, and so on. Now, let's pick the last, on this row, let's pick the last disc. So what's the next thing to do? We drop our discs. Let's drop our discs. We drop our discs. Then to go to pick the last one, we use the forward drive. Then now who can tell us the distance for these discs? Oh yes. If you count 2 to 9, let's count together. 1, 2, 3, 4, 5, 6, 7, 8. Now 8 times 2 is what? Times 200 is what? 1,600. So we'll be driving for 1,600 to get to the position of the discs. Then the next thing to do, we boost, we take our discs. And let's test it and see what we have done. Okay. From here, it shows that we need to call the robot back. So we'll be using drive forward. But this time, when we put it in reverser, 1,600, so it can get back to its base. And we're going to go to the magnet, then select drop. All right. All right, I hope we are all enjoying this training section. Please, if you have not subscribed, if you have not liked, please, it's best to do that because we'll be uploading videos on all this shortly after the training section. Now, to ensure that it has dropped our discs, we do a move forward. We move forward. Let's take 200, let's say 300, so we can see that it is no longer holding our discs back. Let's play over and see what we have done. All right, let me go to a 3D view and replay it so you can appreciate what we have done through the view. Okay. Remember, I told you the magnetic sensor is underneath the robot. It helps the robot to pick the discs underneath it. Okay. Now, I have noticed that the robot works fine, but you know that you can actually increase its velocity, its speed, and its turning speed also. Now let's go to our turning velocity. Let's set a velocity. Now velocity, let's increase it to 100. Now let's run and see what will happen. Now you notice the velocity did not apply to our coding. Why? Because it is placed at the bottom of the code. So we'll just take and place it properly where it should be. We're going to place the code, the set velocity, drive velocity. We're going to set it underneath the start. When started, now from here it now takes effect to apply to all of it. And let's run the code and see how the speed. Now you see, with this we are going to achieve. Okay, now let me just take it back. Let's see how many seconds it takes to achieve that particular task. Is that 7 seconds? So now let's remove the speed, the set velocity, so we can appreciate it better. And let's see how many seconds it will use to achieve this task. You see, it approaches approximately times 2 of its original time used to achieve this task using the drive velocity. So you see that it has used 15 seconds here to achieve that. So that is why, like I said, your precisions and your drive velocity for your robot when it comes to tasks is very important. So we're going to be adding it back. All right, now remember, we still have other ties. We still have other disks to pick up. Now we just only pick the blue disks. I also have the red and the green disks. Now who can tell us what next to do? Yes, somebody said we should continue writing the code. Now I will teach us a shortcut to that. Instead of writing go forward, go forward, go forward, drop, pick, magnetize, and all, you can decide, say, okay, let's just right click. You can use duplicate. You can duplicate the code and you press under. But before then, we're going to be driving. Before then, we're going to be driving. We're going to turn left, turn right, turn right. Then we're going to drive forward. Now we can calculate the distance from this point to this other point. From the center of the blue to the center of the blue, we can calculate the distance for me. Okay, just calculate it. 1, 2, 3, 4. So it's 4 times 200. Remember, I said the boxes are measured in 200 millimeters. So it's 1, 2, 3, and 4. So it will be 800. So I will be driving for 800 after turning right. After turning right, we're going to be driving for 800 millimeters. But this time we're driving forward, not reversal. And let's see what we have done. See, the speed is too much because of those of us that is watching and following. So let's reduce the speed to, let's say, 70%, so we can understand what is happening. You see, it has gotten to the red digs. Now this way, now from here, what's next? We're going to turn left for 90 degrees. Now it is important to know the degrees you're turning to. If you decide to pick turn right, now let me show you something. If that is all this long code, that is why all the logic tool was designed for. So you can go one to any of them to use them, make your code shorter. Now, who can tell us how many times we're supposed to repeat it for the third, that you can achieve the third one? Okay, let's give it a try. Let's say three times, and let's see what it will do. Now remember, we're using logic here. We're making the robot run the code 3 times. All right. Now, you see, we've actually achieved that using our repeat command. And let's see what the forever block, let's see what the forever block. It keeps working and working. In fact, it doesn't get tired until it becomes one of. So using the right code is key and is important. So we're going to be removing the forever. But now I'm going to notice that our drive velocity is actually good. However, we can now move faster, but our turning is still slow. So you just go to the robot drivetrain, then go to turn velocity. Go to the setting, then turn velocity. Let's increase our turn velocity to also 70%. 70%. Then let's go to the logic, add our repeat block, set it to 3. Then all right, I don't know if there's questions. You can leave at the comment section. Or if you think there's something you're not getting right, you can drop your questions on the comment section while we're rounding up our class. Right, see, the turn velocity, I don't know if you noticed the turn velocity, it actually helps our robot in turning fast, and we've gained more time to achieve that particular goal. The other thing we can also use, we can grab sensors too. Now, do you remember the robot? Let me go to so you see. If you look at the robot, it has cameras. You can use sensors to code this, making it more faster, even without using direction. You just tell the robot, wherever you see a green color or a green type, pick it up and drop it at a green box. Look at that, the front eyes. It has the front eyes have the down eyes. Let me turn the camera so you see. Alright, it was indeed an amazing time with you guys, and I really appreciate everyone who have made input, your contributions and your questions. Okay, I will be signing off now. Like I said, if you have a question to ask, you can ask you can drop it at the comment section. But don't forget, like, comment, and share. Now, it helps us to reach out to more people also. Thank you very much. Thank you. While I wait for the moderator to come and take over.
Okay, thank you very much, our dear facilitator. Hope you have been able to enjoy every bit of this training. So up to this moment, we've not seen a question. It means that you understood everything that we said. I don't know if you still have a question, you can drop in the comment section. I know at the point in time, the network was glitchy, but we later came back. And in due time also, we are going to send the completely recorded video of this particular session to our YouTube page so that you can watch in case you miss anything. But of course, it was just for a short time. You can just run through it yourself. I believe that you're able to get everything. So, bear in mind for tomorrow, we have gone through the comment section and we realized that only few schools have sent in their name, the name of their school. So those are the ones that will get the certificate directly from VEX. So we want to be accountable. That's why we're doing this. And you know that this training we're giving you is, you may not know the value, maybe you may not know the value, but it's of high value. It's of high value. And I can just share with you that last 2 months, I gave somebody a gig of just teaching virtually a student, and it got over 300,000 naira the first 2 months, over 300,000 naira in a month just for teaching somebody virtually. So it can be, you can take it as a side gig if you want, but you know, the first thing to everything is about learning, and want to expand the knowledge of robotics to every student. That's our goal, to every student. We want every student to have knowledge of robotics, AI, coding. These are our hard cry. And thank you so much for our facilitator that have taken us on this beautiful journey. I hope that your time worth it. So tomorrow is going to be an amazing time. You don't want to know. Our facilitator for tomorrow is also very equipped and well grounded in robotics. He's going to be taking us on a new chapter of this project. As you can see, yesterday we we didn't do so much of the control. We just tackled the problem, the challenge in a simple way. But today we took it a little bit higher by using an intermediate approach to, and subsequently we'll be taking it higher. That's why we do not want anybody to miss out of this training, because when you participate, you're able to know and you're able to be carried along on all the training journey. So finally, if you have not watched yesterday's video and you're joining us today, please go to our YouTube channel. Yesterday's training is there already. Just go ahead and watch it, then today's on as well. So with this, we are calling the wrap. So if you're not subscribed, if you're not like, I want you to do that right away. Please, we need you to subscribe to our channel. Yeah, we want everybody everywhere. I want this to go viral. I want it to go everywhere. I want every student to have first-hand experience on robotics. And this is what we want to do together with you. Thank you very much, ladies and gentlemen. See you tomorrow. Bye.